Today we are going to learn a small topic in the subject computer-aided design and analysis. Already we are studying 6th module and this is the second part of my presentation. Today we are going to learn interpolation function and strain displacement relationship of CST element. It is a derivation part. For deriving interpolation function, first of all we must consider a constant strain triangle element, which is shown in the figure. It is nothing but it is a 3-noded triangle and each node having 2 displacement. So, from the figure, this is the first node, second node and third node, and the displacement will be u1 v1, u2 v2, u3 v3, and the displacement equation can be written as u is equal to u1 v1, u2 v2, u3 v3. And first of all we must find the area of cross section of the triangle. For that, in mathematical relationship is available. It is a method of deriving area of cross section which is studied in mathematics. If we are going to learn that thing, means this derivation will become very lengthy. Try to by heart this equation. And first of all we must select a linear relationship. In 1D element we have selected it as u is equal to a naught plus a1x, but in this case there are 2-dimensional displacement, our 2D displacement. So this can be expressed as a naught plus a1x plus a2y, that is x will be horizontal displacement, y will be vertical displacement, and it can be expressed in the matrix form as 1 x y into a naught a1 a2, and creating 3 equations, that is there are 3 nodes in the triangle. So creating 3 equations means u1 is equal to a naught plus a1 x1 plus a2 x y2 y1, and u2 is equal to a naught plus a1 x2 plus a2 y2, and u3 is equal to a naught plus a1 x3 plus a2 y3. And it can also be represented in matrix form as u1 u2 u3 is equal to matrix 1 x1 y1, 1 x2 y2, 1 x3 y3 into matrix a naught a1 a2. And we need to find a naught a1 a2. This method is similar to 1D element. For that, first of all we must find the inverse of this matrix into u1 u2 u3. So first of all we must find inverse. For finding inverse, we know the equation. It will be adjoint A divided by determinant A. If we consider this as A adjoint A, then A inverse will be adjoint A divided by determinant A, and adjoint A is the cofactor matrix in the transpose, and we can find the cofactor matrix as like this: a1 a11 a12 a13 a21 a22 a23 a31 a32 a33. Please try to solve yourself. I am not giving much time for this area because it is familiar to you in your +2 classes. And we need to find the determinant, and determinant will be x2 y3 minus x3 y2 minus x1 into y3 minus y2 plus y1 into x3 minus x2. And please try to compare this with the area of cross section of triangle, and you can see that determinant A is equal to 2 into A. And substituting the equation, we will get relation like this. This is determinant A, this is cofactor matrix, and adjoint A means cofactor matrix transpose, that is marked here. So substituting value of determinant A, that is this is equal to 2A. So determinant A will become 1 by 2A, and transpose of this matrix is shown here. you can compare these two equations. Here horizontal line and in here vertical lines are same. Now we are going to substitute value of a not a1 a2 in u equation, that is u will become 1xy into a1 sorry a naught a1 a2. This is the relation we have studied at initial stage in the of the derivation, and when substituting this one, and now we are going to multiply. When multiplying this one, we will get a horizontal matrix, but is the place is not enough for us. So I am representing the matrix in a transpose form, because this term will be initial one, this term will be next one, and this term will be third term. But it is not possible to mark this whole equation in a single line. So I have marked it as transpose matrix, and we know that the relation here comes, it is the shape factor or interpolation function, and this will be n1, this will be n2, and this will be n3. That I have marked here. There is a 1 by 2 outside, so n1 will be like this, n2 will be like this, n3 will be like this. And finally we can write u is equal to n1 n2 n3 into u1 u2 u3, and similarly we can derive the same equation for v is equal to n1 n2 n3 v1 v2 v3. So we can combine both these equations, and finally we will get displacement function as u is equal to u xy v xy is equal to, we can substitute all values. We know that u is equal to n1 u1 plus n2 u2 plus n3 u3. So wherever v1 coming, that should be marked as 0. And the second case, v is equal to n1 v1 plus n2 v2 plus n3 v3, and all other terms will be, that is u terms will be marked as 0. This is the interpolation function derivation. Now we will go to strain displacement function. The strain displacement function start with the displacement function which is derived now, that is u is equal to matrix n1 0 n2 0 n3 0 0 n1 0 n2 0 n3 into column matrix u1 v1 u2 v2 u3 v3, and it can be marked as u is equal to n1 u1 plus n2 u2 plus n3 u3, or v1 n1 v is equal to n1 v1 plus n2 v2 plus n3 v3. First of all, we must know what is strain. For a 2D element, there exist 3 types of strains, or in other words, there will be 2 normal strains and 1 lateral strain. And we have studied these in our mechanics of solid classes, and you know the relation for Ex, Ey and gamma xy. Normal strains will be Ex equal to dou u by dou x, and u is given to us, u is n1 u1 plus n2 u2 plus n3 u3, and Ey is equal to dou v by dou y, or in words dou by dou y of n1 v1 plus n2 v2 plus n3 v3, which is equal to v. And lateral strain or shear strain will be gamma xy is equal to dou u by dou y plus dou v by dou x, and substituting the values, you can see that u1 dou u by dou y will be u1, that is a constant term, and shape function will be derivated or differentiated. So first of all, we must write the equation that will be epsilon x epsilon y gamma xy is equal to matrix dou n1 by dou x 0, dou n2 by dou x 0, dou n3 by dou x 0, second row 0, dou n1 by dou y 0, dou n2 by dou y 0, dou n3 by dou y, and third row dou n1 by dou y, dou n1 by dou x, dou n2 by dou y, dou n2 by dou x, dou n3 by dou y, dou n3 by dou x into displacement. Now we must find all these derivative of shape function. For that we are again writing the same shape function which is derived earlier, that is written here, and from that we are finding dou n1 by dou x, which will be, when we are comparing this equation, dou n1 by dou x should be find, so that we are derivating this equation with respect to x. x2 is constant, y3 is constant, x3 is constant, y2 is constant, so these two elements will be 0. When differentiating this term, there exists x, so when differentiating this term, this equation will become y2 minus y3, and here there is no x terms. This is a x3 is a constant term, x2 also a constant term, so this term will become 0. Finally y2 minus y3 divided by 2a will be dou n1 by dou x. Similarly dou n2 by dou x will be y3 minus y1 by 2a. Dou n3 by dou x will be y1 minus y2 by 2a. Now we are differentiating n1 with respect to y, then this term will become 0, this term also will become 0. Here y will differentiated, so final term will be x3 minus x2 by 2a. Here dou n2 by dou x is equal to x1 minus x3 divided by 2a, and dou n3 by dou x will become x2 minus x1 by 2a. These are the terms. When we are back substituting these values in the previous equation, we can see that this will be the equation, and we have a relationship that epsilon is equal to p into u, where b is the strain displacement relationship, which is already studied in one dimensional elements, and we need to find b element. Comparing these equations, this is strain and this is displacement, definitely this term will be b. When taking 1 by 2a outside, b can be expressed as 1 by 2a into y2 minus y3 0, y3 minus y1 0, y1 minus y2 0, 0, x3 minus x2 0, x1 minus x3 0, x2 minus x1, x3 minus x2, y3 minus y2 minus y3, x1 minus x3, y3 minus y1, x2 minus x1, x1 minus y1 minus y2. This will be our strain displacement relationship. These two things are very important for a CST, and there are plenty of problems regarding this in our text. So we need to solve this derivation again and again and understand wherever mistakes happen. Thank you.